Hello class 9. In our last class, we have seen about the Charles law. We have seen its statement. After that, we have derived an expression that we'll be using for the numerical. Okay. So, today we are going to do the numerical based on the Charles law. So, the formula that we'll be using will be this one. V1 by T1 equals to V2 by T2. Okay. And in Charles' law, you have to keep in mind that pressure remains constant, whereas in Boole's law, temperature remains constant. Okay, so that will help you to distinguish which equations you are going to use. If the temperature is constant, you need to use Boole's law equation, and if pressure is constant, then you need to use Charles' law equation. Okay, so you are going to use this equation V1 by T1 equals to V2 by T2, where V1 is initial volume and T1 is initial temperature. V2 is final volume and T2 is final temperature. Whereas this capital T, that is T1 and T2, represents absolute temperature. Absolute temperature means the temperature in Kelvin scale. Okay, the temperature in Kelvin scale. Now let us see one example to know how to solve the numerical based on Charles' law. So for example, the question is 120 centimeter cube of a gas is taken at 27.3 Kelvin. Okay, so we have got 120 centimeter cube of a gas which is at temperature 27.3 Kelvin. Now the temperature is then raised to 0 degrees Celsius. That means the temperature is increased to 0 degrees Celsius. Then what is the new volume of the gas? After that, you are asked to find out what is the new volume of the gas. The pressure is kept constant. Now, first of all, we are going to write down the givens. What are givens in the equation? Since this volume is given, it will be a V1, initial volume, that is 120 centimeter cube, and is taken at 27.3 Kelvin, so we can take it as T1. T1 as 27.3 Kelvin. Now, the temperature is then raised to 0 degrees Celsius. That means now the temperature, that is the final temperature, becomes T2, that is 0 degrees Celsius. Okay, 0 degrees Celsius. If there is a Celsius unit, you need to convert into Kelvin. Make sure that while doing the numerical, you convert the Celsius unit into Kelvin. So 0 degrees Celsius, when you convert into Kelvin, it becomes 273, because when you convert to Kelvin from Celsius, we need to add 273. So 0 plus 273, it will be 270 Kelvin. And what you're asked? You're asked to find out the new volume, that is V2. Okay. Now the condition has been mentioned. The pressure is kept constant. That means we need to use a Charles law equation. So by Charles law, we have got V1 by T1 equals to V2 by T2. Now what we have found in the givens? So just substitute over there. V1 is 120, then T1 is 27.3, then V2 we need to find, and T2 is 273. So when you just find V2, it becomes 120 into 273 by 27.3. Now when you just simplify it by multiplying and dividing with this one, you'll find the answer as 1200 centimeter cube. So this is the final volume of the gas. Got it? So in this way, you can solve the numerical based on the Charles law. Now the assignment for today, that will be assignment number 6. Okay, for the fourth part test. Question number 1 is convert the following. So you need to do the conversion. So the first is 37 Kelvin to degree Celsius. So you need to convert this Kelvin into Celsius. 270 Kelvin to degree Celsius. Now C is minus 25 degrees Celsius to Kelvin. This temperature now you need to convert into Kelvin, and 27 degrees Celsius to Kelvin. One thing that you have to keep in mind, that when you convert Celsius to Kelvin, we need to add 273, and when you convert Kelvin to Celsius, you need to subtract 273. The question number 2 is 20 ml of hydrogen gas at minus 13 degrees Celsius is heated to 107 degrees Celsius at constant pressure. Find the new volume of the hydrogen. So first over here also you'll write down the givens, and you write down which equation you are using, calculate it, and don't forget to write down the unit at the end, whatever you have calculated. Similarly, question number 3 is, what will be the volume of the gas when 3 liters of it is cooled down from 27 degrees Celsius to minus 78 degrees Celsius at constant pressure? In a similar way, you need to do this numerical as well. Complete it and send it in the mail.